Hello everyone. In this lesson we are going to evaluate, solve, and graph functions written in function notation by using substitution and using a graphing calculator. So let's get right to it. And the do now says evaluate these following expressions. And just remember, anytime they say evaluate the following expressions, all you're going to do is take the x that is equal, whatever they give you, x is equal to 9, and you're going to substitute that 9 in for where you see x. So basically, you're going to rewrite 2 times x. Instead of x, we're going to substitute the 9 in, just like I said. And you can put that in your calculator. It is 18 plus 10. 18 plus 10. Y equals 28. That's it. Again, we're going to substitute this -2 into this equation right where we see the x. So we're going to rewrite this. Y equals 4 times, instead of x, -2 minus 1. Y equals -8 minus 1. And y equals -9. That is all there is to it. And that's it. Let's go on to the next page. So by naming a function f, you can write the function using function notation, right? So with this reads, when you see an f and then an x in parentheses, this reads as f of x. F of x equals 2x minus 3. This is known as function notation. Just a couple of things to remember though. The notation f of x is another name for y. So just remember, when you see this f of x, this is just like y equals 2x minus 3. It's the same thing, right? F of x is the y. So when function notation is used, the parentheses do not imply multiplication. This right here that we're talking about, f of x, that's not f times x. You can use other letters, other letters other than f to name a function. They have g of x, h of x, j of x, k of x, often used to name functions. So these are just a couple of things that we should remember about functions. Going on, match each function with its graph. So this is an activity. Just look at the function and then look at the equation, and then look at the graphs. So we're just going to go and we're going to go down to this one. All right, g of x. If I see this -x plus 2, I know that I'm looking for a linear function. This is linear. Right off the bat, this is linear because it's in y equals mx plus b format. So I'm just going to look for a line that goes straight down from left to right and crosses at 2. So my b, I know right here, equals 2. So this is not this one right here. This is a parabola. It is a U shape. That is not linear. This is linear, but it's crossing. It doesn't cross at -2. That's crossing at somewhere like -3, let's say. This is not linear. This is linear. It's going down from left to right and crosses at 2. So I know that B is this. This is B. All right. If you take your graphing calculator and you want to graph it, you press y equals. And you clear this out, and you're going to put -x plus 2. -x plus 2, you press this graph, and it looks just like this right here, and you know that that is the graph. So we have another linear function right off the bat. This is linear. Again, it's because that is in y equals mx plus b. It has a positive slope. So the m is positive, so that means it goes up from left to right, and the b is a -3. So if we're going up from left to right and the b is -3, that is this one. It's the only other linear that is there. So this is a. So right now I have a and d. Sorry, not d. A and b gone. I knew these were linear. Now, these are non-linear. And the way I know that these both are non-linear, it's because there's an exponent next to the variable in both of these equations. So we're talking about an exponent next to the variable. I am going to go ahead and look at this right here, and I'm going to put y equals, remember what I told you about the the h of x? H of x is y. So this is the y. Y equals x squared minus 1. So the way you do that is you just put x and squared is right there, and then minus 1. And we're going to see what this looks like. It is definitely non-linear. It's a parabola that goes just a little bit below the x-axis. So we are looking at this one. Look at this one compared to this one. So now we're just going to bring up the calculator again. Okay, looking at it, it's this. So C is this one. So we're going to just graph. We know that D is this. We're going to just graph and take your calculator right now, and we're going to graph it just to make sure that 2x squared minus 3 actually looks like that. And it does. All right, take a look at this, and then take a look at this. All right, you know that this right here is kind of like your y-intercept. It's where it crosses the y right here. Even though this is not y equals mx plus b, that this one right here, this is the b. And I shouldn't put a line underneath it. So right here, you could tell that this parabola is going to cross at -1. And right here, you can tell that the parabola is going to cross at -3. So you could use your graphing calculator to help you out, but you could definitely see what the linear functions look like when you have a b of 2. We know that the b of 2 is this, and this is a negative slope. It goes down from left to right. You just have to use exactly what you know. If you don't remember it, just use the graphing calculator. So we're going to consider this function f of x equals -x plus 3. So what this is really is that they're giving you the x, right? So this is the x. Whatever is inside the parentheses is the x. So when you rewrite this, it is f of -1, right? That is your x. That's what they want you to substitute in, right? So instead of x, we're going to put negative and then -1, because we're substituting this -1, that's your x, in for this x right here, and then plus 3. So we have f of -1 is going to be (1 plus 3). So f of -1 equals 4. And look, when x is -1, you can see it on the graph. When x is -1, y is 4. There it is right up there. So when x is -1, the y, the output, is 4. So you could put -1, 4. That is a point on that line. So remember, this is the x, and this is the y, right? F of 0 is the whole thing is the y. But inside the parentheses, that's what you have to substitute into the function. So we're going to rewrite it. F of 0 equals -x. So we're going to put 0 because we're substituting the x in as 0 plus 3. So f of 0 equals 3. So we're going to rewrite this as 0, comma 3. And let's just look at the graph. We're going to see right here, this is 0, and here's 3. The y is 3 when x is 0. Going down to this one, this is my x, the 1, and we want to find out what the y is for f of 1. When the x is 1, what's the y? This is what they're asking. So we're going to substitute the 1 in as -1 plus 3. So we're going to put f of 1 equals 2. So the coordinate is 1, comma 2. And let's check that out. When x is 1, the y is 2. And that does work out, 1, 2. So one more time, this is my x, this is my y, but the inside the parentheses is what you have to actually substitute. So the x is inside the parentheses. We're going to put f of 2 inside the parentheses is what you do have to substitute. And instead of the negative x, we're going to put -2 plus 3. So f of 2 equals 1. -2 plus 3 is 1. And so now we have a 2. When x is 2, the y should be 1. So let's go ahead. It's 2, comma 1 right there. So that's evaluating, consider the function. So when they give you the f of 0 or f of 2, they're really saying substitute 2 in for the x. And then that is the y. All right, f of 2 is the y equals 1 when the x equals 2. Standard notation and function notation. How could you use function notation to represent a function? This is exactly how. How are standard notation and function similar, and how are they different? Well, here's standard notation. You have a y equals, this is the output. And here's the input. Function notation, this right here, the inside the parentheses, that's your input. The entire f of x, everything here, the f of x, this is the output. Whatever's inside the parentheses, that's what you have to substitute in for the x as the input. So whatever they tell you, inside the parentheses, you have to basically input into the x, all right, as substitute into that x. F is the name of the function. This tells you, this x right here, this tells you the input. This tells you what to input, to substitute in for the x, all right, and this tells you what the function does, 5 times the x. And that's it. So evaluate f of 2 equals 5. So I'm going to move this up just a little bit. So remember, this is what you have to input. This is the input. So when you rewrite this, you write f of 2 equals 5 times 2. And f of 2, when f of 2, that equals 10. That means this is the x, and this whole thing is the y. So when you substitute x in as 2, the y, the output, is 10. So if you were going to put this in coordinate form, 2, 10. The x is 2, the y is 10. That's it. So evaluating functions. Let's try it. F of 2. Here's the x. You're going to substitute that in. F of 2. We're going to rewrite f of 2 equals negative 4. And every time I see an x, I'm substituting 2 in plus 7. You could put this directly into your calculator, or you could just kind of figure it out by hand. I'd like it in the calculator. Negative 8 plus 7. F of 2 is negative 1. So if you were putting this into coordinate form, you'd have 2 as the x, negative 1 as the y. X, y, coordinate form. Let's go ahead and evaluate this. Remember, this is your input. That's your x. If that's your input, then I'm going to rewrite at h of negative 7. When h is negative 7, and that's your x, that's your input, 2 over 3. Instead of x, we're going to put negative 7 minus 5. Now I'm going to grab my calculator because I don't want to do this by hand. And I'm going to press alpha x. And we're going to have 2 over 3. And I'm going to put in parentheses negative 7 minus 5. Just exactly the way I see it here. So I'm going to press enter. And that is negative 29 over 3. Once I get negative 29 over 3, I just don't want to keep it that way. I'm just going to divide the two numbers and see exactly what it comes to as a decimal. And I am going to put down that it is negative 9.7. Rounding it to the nearest tenth. Okay. All right, try this. Evaluate the function when x equals negative 4, 0, and 3. So, just remember, instead of f of x, we're going to go to negative 4 first. We're going to substitute the negative 4 in. When we write it, it's 2 times negative 4 minus 5. So, f of 4, negative 4, equals negative 8 minus 5. Grab your calculator. 2 times negative 4 minus 5. Make this a little bit bigger. Minus 5. And we have negative 13. So this is negative 13. F of negative 4. And we move this over here. The next one I'm going to do is 0. This should be nice and easy. F of 0 equals 2 times 0 minus 5. 0 minus 5. F of 0 is negative 5. Then I'm going to go f of 3 equals 2 times 3 minus 5. So it's 6 minus 5. 6 minus 5 is 1. So these are the answers right here when x is 3. Y is 1. When x is negative 4, y is negative 13. When x is 0, y is negative 5. So we're going to do the same thing in g of x, and we are going to substitute again g of negative 4. We're going to start off with negative 4 equals negative 4. We're going to substitute that in, and then we're taking this negative right here from the function itself. G of negative 4 now equals negative, and negative is a positive 4 minus 1 and then g of negative 4 is 3. That's your answer for that. Let's go ahead and substitute 0 in, and 0 is going to be an easy one. 0 is not positive or negative, so you're just going to leave it that way, minus 1. So g of 0 equals negative 1. And then the last one, g of 3 is negative, so we're going to substitute a 3 in, and remember it's going to turn negative minus 1. So we have negative 3 minus 1, and g of 3 is negative 4. You do this on your calculator, do it step by step, and that's basically it. So now that I showed you that, remember, this is my x, and these are we're evaluating these functions. So I'm going to bring up the calculator right now and see if I could use the calculator in a way that makes it a little bit easier for us to do. So remember, we always say that we could use the calculator every step of the way, and we can. So if they give you an equation like this, right, and they want the x, they want you to evaluate for negative 4, the x's of all of those, we could just go ahead and put this into the calculator, negative x minus 1, right? Now, we don't care what the graph looks like, so we're going to press second function and table. We have this table right here. Do you see this negative 4? So if we press up and we see this negative 4, look, it's 3. When x is negative 4, the y is 3. All right, the output is 3. So now we're going to go down to 0. 0. 0. When x is 0, what's the y going to be? Negative 1? Look, I have my negative 1 here. So you could really just put this equation in and then just figure it out, and then you could see what the y is. The calculator does the work for you. So you could say, evaluate this for when x is 10. All right, 10, right here. So the y is negative 11. That's it. All right, I would do that pretty much 100% of the time. So just take a look at the other one. And you have 2x. Oh, it's 2x minus 5. We're going to press y equals. We're going to clear that out. And there's 2x minus 5. And we're going to press second function graph. We don't care what the graph looks like. We have to evaluate it for negative 4. I'm going to go up to negative 4 right away. And it's negative 13. See my answer? It's there. Then we evaluate it for 0. It's negative 5. See my answer? There. 3. 1. 1. So just remember, there are different ways to do this. If you want to go ahead and actually substitute in, then you do. But if you don't want to do that and you want to just make sure that you get it completely correct 100% of the time, calculate is the best way to do it. All right, here we go. So this is a little bit different. So it says, find the value, says for h of x, 2 over 3x minus 5, find the value of x, find the value of x for which h of x equals 6. Notice that there's no number inside the parenthesis. They're giving you what h of x is equal to. So it's kind of like saying y is equal to 6. That's what this is. This is basically saying y is equal to 6. They did not mention what x is. They want you to find x. So instead of h of x, now we're going to substitute the 6 in. So here we go. H of x is 6 equals 2 over 3 x minus 5. To get x, you have to add 5 on both sides. This cancels. You have 11 equals 2 over 3x. And then we times, multiply by 3 over 2 times 3 over 2. This cancels with this. This cancels with this. X equals 33 over 2. And let's just make sure. 33 over 2 16.5. There's x. So when they give you h of x, you have to solve for the x. And it says find the value of x. So let's move that over and let's go to do the second one. Again, they want you to find x, right? They're giving you what y is. So instead of h of x, we're going to put 12 in. Substitute that 12 in. 2 over 3x minus 5. You add 5 to both sides. This cancels. This is 17 equals 2 over 3x. You multiply by the reciprocal. This cancels with this. This cancels with this. X comes down, equals, and we're going to use our calculator, 3 over 2 times 17. So, alpha x, 3 over 2 times 17. Enter. 51 over 2. I'm going to convert that real quick. 51 divided by 2 is 25.5. That is my answer. One more, 102. So I'm going to substitute 102 in for h of x. 2 over 3x minus 5. I am going to add 5 on both sides. This cancels. Plus 5. This is 107 equals 2 over 3x. I'm going to multiply 3 over 2 over 3 by the reciprocal of 3 over 2. This cancels, this cancels, this cancels, this cancels. X comes down equals 3 over 2 times 107. That's way above what I want to do. 3 over 2. Times 107 equals 321 divided by 2. 321 divided by 2. 160.5. Just remember, when you have to solve for the x, they're going to give you what the y is, right? They're giving you what the y is every single time here. Whatever is inside the parentheses, that's what you substitute in for x. If you're given h of x equals 6, that is the y. That's the output. They want you to find the input. So it says find the value of x. Find the value of x so that the function has the given value. So this is, remember, find the value of x. There's nothing inside those parentheses. So this is like y equals 21. So we're going to substitute the f of x in as 21 and then 6x minus 9. And we're just going to go ahead and solve for x. This cancels and you have 30 equals 6x. And divide by 6, and you have x equals 5. Find that value of x, you did. Remember, g of x equals -1, so we're going to substitute in -1 as g of x. We're going to subtract 3. Now we're going to solve for x, like we know how to do. So this is -4 equals -1/2 x, and then we're going to multiply by the reciprocal. Just like that, and then you are going to have this -1 and 1 cancel, -2 and 2 cancel. This x comes down, and you have -4 times -2 is a +8. So x is 8. That is it. Okay, comparing graphs of linear functions. So just remember what you've learned about graphing and slope and y-intercept, that still goes here. It's like y equals mx plus b. That's exactly what this is. This is y equals mx plus b. So determine the slope of this g of x. The slope is 1. It's always the number before the x. And then the slope of f of x is 1. Always the number before x. Determine the y-intercept of g of x. That's the other number. That's your b. -3. And then the other number, which is nothing there, it is 0. What can you conclude of the two functions? Well, you could say that they are parallel. They have the same slope because they are parallel, the same rise and run. One is a direct variation. F of x is a direct variation. Goes through 0, 0. So those are the things that you can conclude about the two functions. So if you want to copy that down, g of x and f of x are parallel because they have the same slope with different y-intercepts. And then also we can conclude that f of x is a direct variation because it goes through 0, 0, has a y-intercept of 0. A lot of people like to say there's no y-intercept. There is a y-intercept. The y-intercept is 0. So we are going to graph these functions, and just remember these are all just y equals. So it's not anything that you haven't seen before. Y equals, y equals, y equals. So these are the functions right here. You could graph them by hand or with the calculator. We are going to do a little bit of both. So f of x, which is y equals 2x, the m equals -2. Since I'm graphing, I'm going to put it in rise over run format. The b equals 0. So I am going to start at 0. That's where I'm starting. And I'm going to go down 2, right 1. Down 2, right 1. And this is by hand. Nice and easy, just like this. Up 2, left 1, opposite. Up 2, left 1. You connect with a straight line using a ruler. Remember, you must put arrows on either end, on each end, I should say, and then put y, not y, f of x equals -2x. So let me grab the calculator, and I'm going to go to y equals, and I am going to clear that out and press -2x. Y equals -2x. There is my graph. That's what I graphed. I have a direct variation there. Press second function and table again, graph again, and you have all of your points that you could use to graph this line. Now I'm going to go to y equals, going to go down to y2. And instead of doing this by hand, I am just going to go ahead and All right, this is a slope. This is a little bit by hand here. And then the y-intercept is 3. So you know that the g of x has the same slope as the f of x. So these are going to be parallel lines. So it's negative 2x plus 3. We're going to put this into the calculator, negative 2x plus 3. And we're going to press graph. And yes, you see that red line? That red line is parallel to that blue line. So when you read this in your graph, negative 411 is the first point, and negative 3, well, you can't fit that on a graph because it's 10 by 10, but negative 3, 9 is the next. So I'm going to go negative 3 over 1, 2, 3. That's negative 3. 9 is all the way up here. So I'm going to put my first point right here. Then I'm going to go down to negative 2, 7, negative 2, 7. Right here. You see this is down 2, right 1. Down 2, right 1. My y-intercept should be 0, 3. And look, 0, 3. See the y-intercept? And then down 2, right 1. I'm not going to look at my graph graphing calculator again, only because I know it's down 2, right 1, because it's a negative 2 slope. Once I get this out, I'm going to go ahead and connect my lines, my points, and I'm going to put an arrow on the top and an arrow on the bottom. And I am going to label this one g of x equals negative 2x plus 3. Now I'm going to go to this one right here, and I am going to put that the slope is negative 2 over 1 again. So this is another parallel line down and to the right. And then the y-intercept is negative 5. So my y-intercept is all the way down here. 1, 2, 3, 4, 5. So I'm going down 2, right 1. Down 2, right 1. If I use the graphing calculator, I'm going to press y equals and then go down to y3, and it's negative 2x minus 5. And you could see what the graph is supposed to look like. I have a third line that is parallel. If I want to get the points, I go ahead and look, and I know that my 0, negative 5 as the y3, you're reading from x to the y3, which is the negative 5. And I do have negative 5 right there. I'm going to go up 2 to the right, to the left 1, up 2 to the left, up 2 to the left, up 2 to the left. And you just keep on going like this. So I'm going to connect those points with a straight line using my ruler. Move this over here since this is a little bit messed up. All right, and we're going to put arrows. And we are definitely going to label this h of x equals negative 2x minus 5. So these are the three lines. So how does g of x compare to f of x? Basically the same answer for both. They are parallel because they have the same slope with a different y-intercept. All of these lines, though, are negative, right? They're going down from left to right, and that is that. All right, that's it. Hopefully that helped. All right, the mid-lesson assessment. Go ahead, try to do this, and see if you can press pause. We'll come back and review the answer. Try this problem, press pause now. So this graph shows the number y of miles the helicopter is from its destination after X hours on its first flight. So here's the distance right here, and you see it that this helicopter starts at 300 miles and then takes 3 hours to get from its destination. So the second flight, helicopter travels the same speed. So that means you know that if it travels the same speed, you're going to have a parallel lines. You know, we're going to have two parallel lines. Same speed, but 50 miles farther. So we're kind of looking like that. That's where it starts. And we're going to go down like that. Same speed. So which statement is true about the graph of the function that represents the second flight compared to the graph of the function of the first flight? The slope increases? No, it's the same slope. So we could cross those out. The graph is a translation. A translation is a movement. So it's not 50 units down. Actually, if they went 50 miles less, it would be down, 50 miles down. It would start here if it went less. It's obviously a translation up because this started at 350 miles, 50 miles farther. All right, same speed, 50 miles farther. If you pick D, that is great that you did. All right, this is independent work. Go ahead, see if you can figure all of this out. Remember, when they give you the number inside the parentheses, all you're doing is actually putting the x, substituting the x in. So just give it a try, and then we'll come back and go over it. You can press pause now. So number one says your height can be represented by function h of x, where x is your age. And obviously I put 13. X is the age, so h of 13. So really what they want there is your height. So let's just say you're 5'4". 5 times 12 is 60 plus 4, 64 inches. So you could say 64 inches. And then everybody's going to have different answers because everybody's different heights. All right, so, but let's go on to number 2. We're going to substitute this -2 in for the x. So -2 plus 6 is 4. 0 plus 6 is 6. 5 plus 6 is 11. G of x. Now, just remember, if you take this g of x, this is 3x minus 2, and you clear all this out, (3x minus 2). If you don't want to worry about anything, you could just go and get the list of values right there. So the first one is -2. Well, I know -2 is -8. I know 0 is -2. And I know 5 is 13. And think about it. 5 times 3 is 15 minus 2 is 13. 3 times 0 minus 2 is -2. 3 times -2 is -6 minus 2 is -8. So you really don't have to do any of that. Just remember, for number 4, it's nice to know how to do it by hand and also do it on the calculator. This is a -x. So if you're already substituting a negative, it turns to positive. So this is 2 minus 7. 2 minus 7 is -5. 0 minus 7 is -7. -5 minus 7 is -12. And again, if I get my calculator up, clear this out, -x, just want to check to see if I'm correct. 7, and then press second function table. all of my numbers here. -2 is -5. That's correct. 0 is -7. That's correct. 5 is -12. That's correct. Done. Find the value of x. This is different now. Remember, so we have h of x. We don't have anything inside those parentheses. So h of x is 3 equals -7x plus 10. This is where you have to solve for x. -10, -10. And we are canceling this out. -7 equals -7x. You divide by -7. X equals 1. 4. Substituted in for j of x. 4 equals -3x minus 5. Add 5 to both sides. This cancels. You have 9 equals -3x. Divide by -3. Divide by -3. X equals -3. P of x equals 3. 3 equals 6x minus 12. Add 12 on both sides. This cancels. You have 15 equals 6x. Then you divide by 6. Divide by 6. X equals 15 divided by 6. So I'm going to just graph and clear 15 divided by 6 is 2.5. Just to make sure. And that's that. So this is an Explore. You earn $11 per hour working at a grocery store during the summer. $11 per hour working at a grocery store. The function P of x equals 11x. This is $11 an hour. So it represents the amount you earned for working X hours. How much do you earn if you work 18 hours? So the hours is X. So we have this. So I'm going to write down P of x equals 11x. I'm making $11 an hour. So my number of hours that they want me to find out is 18. 11 times 18. Grab my calculator. 11 times 18 is my answer. I make $198. So P of 18 equals 198. Remember, the input is inside the parentheses. Inside the parentheses input, the output is the other number. How many hours do you have to work to earn $275? A little bit different. They're not giving you how many hours that you worked. They want to know how many hours you work. So this is the total. So the total is what P of x is. So this would say P of x equals 275. So if the P of x is 275, you have to substitute the 275 in for P of x. And you have 11x. Then you divide by 11. You're going to solve for the number of hours, which is x. So we're going to grab the calculator, 275 divided by 11. 25 big hours. And that is your answer. So on your own, match the function with its graph. Let me just say that you really should be able to do this without the graphing calculator. But if you need the graphing calculator, you put y equals -2x minus 2 and you match that up. But the thing is, if you know that this slope is -2 and the y-intercept is -2, and you know that this slope is a half, which is not that steep, and b equals positive 2, and you know that this slope is a half, and the y-intercept is negative 2, you can kind of eyeball it. So the graphs here are going by 2's, so just be careful, right? So this right here, I'm just picking C, random, right? This is a negative 2 y-intercept, and it's going down from left to right. Down from left to right, this is a negative slope. And it crosses this B equals negative 2. So which one is a negative slope that crosses at negative 2? Yes, this one. So this is C. Negative 2. So now I have a y-intercept of positive 2. This one has a y-intercept of positive 2, and the slope is 1/2 if you look at it, but it doesn't matter, it's positive. Right? This is a positive slope, so this is a positive slope with a b of 2. The b is 2. So this one is b. Obviously, this one is A, but if you look at it, this is a positive slope up from left to right. And it crosses at negative 2. So you can sit there and graph these on your graphing calculator and get the answers. But you should really be able to recognize, one, you're checking to see if it's positive or negative slope. 2, you're checking to see where it crosses the y-axis. Then the last thing that you do is actually the rise over run. I didn't need to do any of the rise over runs for any of these. I was able to put whatever graph, match any graph with its function just by looking at the y-intercept and looking to see if the slope was positive or negative. All right, here are 2 regions questions. Give them a try. And I think there's 2 more on the bottom. So go ahead and, there's 5. Do all 5, and then we'll come back and we'll discuss how you get these answers, and we'll see if you're correct. All right, try these problems. Press pause now. So take a look. Which point could be used? And I'm just going to highlight f of negative 2. Just remember what I said. If the negative 2 is inside the parentheses, that's the x. So if this is the x, this is the input. At negative 2, here's 0, 0. Negative 2 is right here. So if you circled C, that's great. Here's the x again. What's the value when the x is negative 3 of y? So when you substitute this in, let's see, let's go over to x is negative 3. Negative 1, negative 2, negative 3. What's the y? 1, 2, 3, 4, 5, 6. So when x is negative 3, y is 6. That's how you do that. Look how nice and easy these regions problems are. All right, so f of negative 3. F of negative 3. This is how to do it by hand. 4 times negative 3 plus 5. This is negative 12 plus 5. And it is negative 7. So I'm getting a little confused here. Okay. Again, you can put this into your graphing calculator, look for where the x is -3, and get the y. All right, function g of x is defined as this. You bet I'm going to use my calculator. So I'm going to grab the calculator. Clear it out. Y equals, clear it out. We're going to put this exact function in. This is -2x squared plus 3x. Yeah, I don't want to do this. Right? I'm going to press second function table. I'm going to go down to where x is -3. Passed it. -27 is my answer. Voila. Easy, easy, easy. All right. So this one might be a little bit difficult, right? But we're going to do it by hand first. And then I'll show you a little trick with the calculator. So I'm substituting this in as my x. So I'm going to put that as 0.5. It's a half. Plus 3. Then I'm going to put 6 times 0.5, which is a half, minus 5. 2 times a half is half of 2, which is square root of 1 plus 3. And 6 times 0.5, which is half of 6, is 3 minus 5. Well, alrighty then. Square root of 4 over -2. Square root of 4 is 2 divided by -2 equals -1. So that's what that is by hand. Just slowly going through. Remember, you're allowed to change a half to a 0.5. Make it easier for yourself. I did that without a calculator. So how do you put this in a calculator and get your answer? Because it's a half, right? So let's go ahead and concentrate on the function itself. So this is alpha x, and then that'll bring up the fraction symbol. You could also go to alpha y, and that'll bring up the fraction symbol as well. But I don't do that. I just go right to alpha x, and that brings up the fraction symbol. So then you press second function again, and you will press x squared, and right above x squared you'll see that there is a square root, and then you press 2x plus 3, and on the bottom you get 6x. You have 6x minus 5. So this is basically how you would put that in, and then you would go to second and table, and you'll see a whole bunch of numbers here in this like error. Don't worry about the error. It means that you can't get an answer if you put these numbers in. And then the first answer you'll get, if you put f of -1 in, you'll get -1 over 11. What's missing here, though, is that you have to get a half. You have to substitute a half in. And you have to see where the x is a half and what the y would be at when an x is a half. Because if you can't see that, then the graphing calculator is kind of like not useful. So what you do is you press second function and table set. You see the table start is -4. Sometimes I set it to 0. Sometimes I just leave it. It doesn't matter. But the table start is where the table you want the x to start. So if you wanted to start at, like, say 100, and then you enter it, you would press second function table, and you could zoom to 100, which is great because, again, like, who wants to press the down button 100 times to get where x is 100? So you don't want to do that. So you press second function window, which is table set, and you're back at this. So I'm going to put this back at 0 because I don't want to start at 100. But this table setting right here, and it's that at table. So it tells you that's going to tell you what the x is increasing by or decreasing by. It's going by ones, all right? And that's the input. If I want to see a half, I'm going to change that to 0.5. Now, my whole table is going to change right now, second function table, and you see it goes by halves now. And now I want to see where, when the x is a half, what the y is going to be, and it's -1. So you could see basically that when the x is a half, the y is -1. I did it by hand, but you could do it in the calculator as well. And I would do it in the calculator. Why not? Right? So, and those are the 5 Regents questions. All right, here's the exit step again. Try these problems, take a little bit, circle your answer, and then come back once you have those answers. We'll go over them and see if you get them right. All right, press pause, try the problems now. So in all honesty, you see this is right here. It's a trinomial. I am not going to substitute this -3 in and find out what that is as a value. I'm not doing it. So I'm going to grab the calculator. My calculator is my friend. And I'm going to substitute that in. I'm going to clear out that mess that I had before. I'm just going to move this over. And I'm going to have 2x squared. So it's y equals 2x and then squared minus 5x plus 3. All right, that's what I have. That's what my question is. And don't forget the second function table set. I changed it to 0.5. I don't want that anymore. I want 1. And I start at 0. So second function table, back there. I'm going to go up to -3. When x is -3, it is 36. Boom, it's done. That's it. Okay. Which chart could represent -2x plus 6? First off, this y-intercept is 6. So which 2 can you cancel out? If the y-intercept is 6, b equals 6. I'm not even using the calculator for this. So I know I have to have 0,6 in my table. I have 0,6 in this table, so this is good. I have 0,8 at this table, that's gone. 0,4 at this table, that's gone. 0,6 at this table, that's good. Remember, the input and the output has to match. So if I take, let's go over here because I see negatives here. Let's go to this one. So 2 to 10. If I substitute 2 in here, I'm supposed to get 10. So I'm going to do f of 2 equals -2 times 2 plus 6. This is -4 plus 6. That is not 10. That's out. I just want to try this 2. Oh, by the way, that's the same thing. All right, so f of 2 equals -2 times 2, I'm trying, plus 6. That's -4 plus 6. F of 2 is 2. This one works. D is your answer. If you really would like, you go to your table. You go to your calculator. You put -2x in, plus 6. Press second function graph. You get your table, 0,6, 2, 2, 4, -2, 6, -6. It's D. That's it. You could use your calculator, or you could kind of substitute the hard way if you really want to. It doesn't matter. It's not really difficult. I said really the hard way, but it's not really that hard. All right. So D is your answer there. And thank you for watching. I hope it helped. And that's it. I'll see you next time.